Now, this is just a quick video to help you with one particular question in an exam. And that question is, which type of graph? Which type of graph should the student draw? Why has the student chosen to draw a bar chart? Why has that student chosen to draw a line graph? Now, the first thing to answer this question is to realise that in GCSE science, there are only two types of graphs you can be asked to draw or asked about. There are loads of types of graphs in the real world, but in GCSE science, we're bothered about line graphs, the ones with the little X's, where you end up drawing a nice, neat line of best fit through them, or a bar chart, where you draw bars up to the correct heights to show how much of something you've got. Now, to decide which type of graph I should draw depends on the data I have. So, bar charts should be drawn if any of the data is not continuous. So, if I got asked an exam question that said, why has the student drawn a bar chart? It must be because some of the data wasn't continuous. So, if I was asked, why have they drawn a bar chart? I would write this top bit. Now, the bottom bit is non-scientific. I wouldn't write it, but it's what I would be thinking. It's how I can tell. Data that is not continuous generally appears as words in a table. So if I'm doing that experiment where you heat up different coloured beakers to see how hot the water gets, and I had a black beaker and the water got to 30 degrees C, I had a silver beaker and the water got to 10 degrees C, and I had a white beaker and the water got to 20 degrees C, well, I would know to draw a bar chart because, well, this column is words and words are not continuous, so I would draw a bar chart. So I would draw a bar chart of this data. I would have a bar for black, a bar for silver, a bar for white, and the bars would go up to the correct temperatures. And if the examiner asked me, why should I draw a bar chart? Because that data is not continuous. Now, because there's only two types of graphs, that means line graph has got to be the opposite. So line graphs should be drawn when all of the data is continuous. So if the exam asked me, why has this student drawn a line graph? Well, because all of the data is continuous. That's my scientific answer. That's what I would write. The bottom bit is what I'm thinking. It's how I can tell. Continuous data appears as numbers. So for example, if I do that classic experiment where I add weights to a spring, well, the weight would be numbers. 5 newtons, 10 newtons, 15 newtons, 20 newtons, 25 newtons. So that would be my force in newtons. And then the other column would be extension, which would also be numbers. So 2 centimeters, 4 centimeters, 6 centimeters, 8 centimeters, 10 centimeters. They're both numbers. That means they're both continuous. So I would draw a line graph. Now, looking at a quick couple of example questions. So I've removed the method, I've removed the diagram. You can't even tell what this is about. But it says the table below shows the results. What is the best way for the student to display the results? Well, in GCSE science, your only options are bar chart and line graph. So I can get rid of frequency table, I can get rid of pie chart. The first column is numbers, which means it's continuous. The second column is numbers, it's still continuous. Both are continuous, so I would draw a line graph. Another question, again, I've got all my method, everything going on here. But it's again saying, how should the results of the investigation be displayed? Well, it's got to be bar chart or line graph, so I can remove histogram. I think you do those in maths. I can remove pie chart. I think you do those in maths. But I'm left with bar chart and line graph. So I better work out from this method if the data is continuous or not. So a student investigated the temperature change of different masses of calcium carbonate. So they're going to have different masses of calcium carbonate. So if I did a table of this, I'd have a mass column. Well, that's going to be numbers. That's going to be 5 grams, 10 grams, 15 grams, 20 grams. So that would be numbers. That's continuous. And then they want the temperature change. So temperature change Well, that would be in degrees C. That would be numbers. So 3, 6, 9, 12. They would both be numbers. So line graph. Reason, all of the data is continuous. Now that question was harder because I had to give a reason for a start and because I couldn't just see a table. I had to work out what the table might be. Now, the final question, this actually doesn't ask why I've done this type of graph, but I just wanted to show you the opposite. So this one, I've got my table. Well, that column is not numbers. That column's not continuous, so they've drawn a bar chart. But the actual question is, the students made some errors when plotting the bar chart, give 3 errors. So I just have to look for what's missing or what they've done wrong. Well, there you go. There's a label missing there. So they have not labeled the zinc bar. Right, what else are we missing? So we've got all the numbers at the side. They go up correctly. Mean temperature increase in, well, the unit's missing there. So the unit degrees C is missing from the y-axis. Now, I can't see anything else obvious, so I'm inclined to check how high the bars are. So iron should be 6.5, 5, 6, 6. But yeah, iron's probably right. Magnesium should be 18. Oh, there you go. Magnesium's only 15. So magnesium bar is not up to 18. So there's some questions just about why you pick certain types of graphs.